Hello everybody. So today we're going to continue through our new unit, which is finance. So quick review of what we did last day. We took a look at simple interest, where our formula was I equals PRT. P, of course, is our principal or our starting amount. R was the interest rate, and T was the amount of years we were leaving the investment to gain interest. So today we're going to start talking about the other kind of interest, which is compound interest. Okay. Um, so the difference between simple interest and compound interest basically lies in what the value of P is, our principal or our starting amount. So for simple interest, our principal amount never changes. It always stays the same, regardless of how long we're leaving the investment sit to gain interest. But with compound interest, it changes. Usually it's every year. In this section of the book, we're just going to deal with yearly, we call them compounding periods, hence the name compound interest. We say that every year the interest is compounded. In this section, it's going to be every year. It doesn't necessarily have to be every year. It could be every week, every month, every half a year, whatever. But in this section, we're just going to keep it simple. We're going to say that our p-value changes every year, or that the interest is compounded every year. So what does that mean? So let's say we let an investment sit for more than a year, right? Let's say we let it sit for, I don't know, 4 or 5 years. So during the first year, you get interest as normal. But at the end of that first year, we take the interest that you've gained and we put that back in to the initial amount. And when we add that new interest after 1 year to the initial P amount, we get a new P value for the next year. We get a higher P value. So the second year's P value is the first year's P value plus the interest in that first compounding period. In this case, that's 1 year. And then the second year goes by, it gets interest. And at the end of that second year, we take that interest, add it back to the previous P value, and we get the next year's P value. So every year, our P value gets bigger and bigger and bigger until the investment ends. Okay? So what we're going to do is we're going to do a little exercise here that's going to kind of help us see what's going on. Okay? So what we have is two types of savings bonds we have at a bank. The regular one, which just pays simple interest at 9% per year or per annum. And then we have the compound one that pays the same amount of interest, compounded annually. So that means compounded every year. So what we're going to do, we're going to have an initial p-value of $15,000. Okay, so for the first one, it's simple enough. If we take 9% of 15,000, that gives us $1,350. Okay, every year. That's what simple interest means. Essentially, this was I equals PRT, right? So our principal value was 15,000. Our interest rate was 0.09. And for each year, our T value is going to be 1 because it's 1 year. So that gives us 1350. Okay. All right. So here, as you can see, looks like we're going to let it sit for 8 years, gaining that amount of interest every month. Right? So what we can do here is to finish filling it in. So if we add 1350 to that one, we get $23,100. We get 24,000, or sorry, yeah, 24,450. And then at the end we get $25,800. Okay. So our 15,000 became $25,800 after 8 years. Pretty good. Okay. But that's a review. We should be pretty comfortable with simple interest. So now let's take a look what happens when we use compound interest. Okay. So this is going to be at the end of year 1. So the value of the bond, as normal, we take our principal amount and we add our interest. Okay. So what we have here, we have that $15,000. That's our principal every time. That's what we started with, right? And then over here, what we've done is we've taken that 9% in the first year. Right? But notice how here and here we have $15,000. So we just factor out 15,000. So that's this guy here. Okay. And then if we factor out 15,000 from 15,000, we get 1. And then we just have the 9% over here. Okay, so this is just a fancy way of calculating what our interest is going to be, or sorry, our total amount in the account is going to be after the first year. So if you go ahead, you take 15,000 and you multiply it by 1.09, you get a value of $16,350. Right, if you notice, that's the same as the simple interest, right? But now, what we're going to do is we're going to go to the end of year 2. So what we've done here now is a little different, the way this is set up. So here we've taken, this is our $16,350 right here, right? That's what we did up here, right? We ended up with 15,000 times 1.09, right? But now what we're doing is we're taking that, and to that we add the original amount plus, or sorry, not the original amount. What we have here again is the same as right there. That's the amount of money we had at the end of year 1, but we're not adding all of it, we're just adding 9% of it, right? Because now we're in the second year, we have to compound that amount, so we take 9% and we add it to what we had at the end of the first year. So this is end of first year. Amount. And to that, we're adding 9% interest on the end of the first year. Right, so our 9% is right there. And then, like I said, this is just our 16,350 there. The exercise does some algebra to simplify it out. All it's doing is showing you that we're just going to multiply by 1.09. to the power of how many years we've waited, right? So again, let's do that at the end of year 3. So now this is our new principal with all that interest included, right? And to that now we're adding the next 9%, the next compounding period of the end of the second year amount. This is the end of the second year amount, right? It's the same as this one, right? So as you can see here, again, this ends up being 15,000 times 1.09 squared times 1.09. And of course, that simplifies to 1.09 to the power of 3, because now we've waited 3 years. Right? So now we can extend that pattern. So of course, this is going to be 15,000 times 1.09 to the power of 4. This is going to be 15,000 times 1.09 to the power of 5, the power of 6, power of 7, the power of 8. Right? And then it just goes, you know, however many big as you want it to go. Okay, so we can go ahead and we can calculate this if we want to. So that's going to be 15,000, or actually here, what I'll do instead is I'll do 1.09 to the power of 4 times 15,000. So there, that gives you $21,173.72. $1.09 to the power of 5 times 15,000 gives you $23,079.36. Oops. 1.09 to the power of 6 times 15,000 gives me 25. $156.50, and I mean, you get the point, right? It's getting larger. Okay. So what does that mean? Here, what we're going to do, or what the exercise wants us to do, is it wants us to make a graph, 2 graphs, one for our simple interest that we saw here, and one for our compound interest that we saw here. I'm not going to do that. It's going to take quite some time. What you actually end up getting is something that looks like this. Okay. This graph is extended to 25 years, but the idea is the same. So what we get here is, this is our simple interest. All right. So this is the number of years that we let the investment sit, and then on the left here is how much money in the account. Okay. So if it's simple interest, you can see that it's a linear function, right? It only increases the same amount every time, so it's constant. It doesn't change. But what we have here is our compound interest. And if you take a look at that, you should think, hey, that's an exponential function. Okay, it's increasing exponentially. It's curving upwards. All right. And in fact, well, hey, if we take a look at that formula that we got for the compound interest, right, this guy right here, So this is our total amount. That's 15,000 times 1.09 the power of n. That's an exponential function. This is y equals a times b to the power of x, right? So it's an exponential function. So we would expect this kind of shape. Now, what does this mean? What do these two shapes mean? Why do we care about it? Well, if we take a look, let's say after 20 years, look at the difference of money you'll get at the end of 20 years. If your interest is compound interest, you make $85,000, but if your interest is simple interest, you make like $43,000. You make almost half. So the whole idea behind this exercise was twofold. First, compound interest will pay you more interest over the same period of time because it's exponential. That line curves upwards, so you'll get more. And second, to understand that compound interest, in fact, is exponential. It's an exponential growth. Okay? So use the compound interest graph to estimate the number of years it would take for the initial investment of $15,000 to increase to 50. So 50,000 right here, right? So we follow along. It's right there, so we'll come down. Looks like that's about 14 years, right? So $100,000, that's up here, right there, go down. It's going to be 22,000 or 22 years. Right? So notice how, right, the difference between 50,000 and 100,000, that's times 2, right? 100,000 is twice as big as 50,000. But notice how it takes 14 years to get 50, but it doesn't take double that amount of years to get to 100,000. It takes less. That's because it's exponential. It's increasing faster every year. So, double the amount of years here would be 28 years, but we don't have to wait 28 years. We only have to wait 22 years. That's because the graph is exponential. If it was a linear function, if it was simple interest, it would take us double the amount of years to double our total. But with exponential, we don't have to wait as long because you get more. Consider an investment of 30,000 compounded annually at 5% every year per annum. Write an exponential function which represents the final amount, a after n years. Well, we saw that all we needed to do from up here is you take your initial amount, multiply it by 1 plus the interest rate, and raise it to the number of years you're letting it sit there for. So the starting amount in this case is 30,000. The interest rate is 5%. So that's going to be, 1 plus 5% is going to be 1.05. And it's n years, right? That's it. If we wanted to know the amount in the account, after 2 years, we would change n to 2, do the math, we'd get the amount. Right? Consider an investment of $750 compounded annually at 3.5%. Write an exponential function which will represent the final amount after n years. So same question with some different numbers. So again, it's going to be A equals our P value, our principal amount, 750 times 1 plus our interest rate. So our interest rate is 3.5%. As a decimal, that would be 0.035. So 1 plus 0.035 would just be 1.035. And we let it sit there for n years. Okay. In general, if A equals the final amount, or the value of the bond, just the final amount, P is the principal, I is the initial interest rate, and N is the number of years, we get the formula I'm not going to write it down because I put it here. So this is our compound interest formula, where A equals the final amount. P is still our principal. I is the interest rate. Similar to our R value in the simple interest formula, and N is simply just number of years. Okay, the N value, like I said, we're going to take a look at, different compounding periods in the next section. So this N is not always going to be just number of years. It will be for this part of the homework. Okay, so just think of it like that for now. Just keep in mind later we're going to change exactly how that N value works. Okay. Yeah, that's a bit of a note there. Don't worry about it now. And again, notice how this one still is in the form of y equals a times b to the power of x, which is our exponential function, right? So we have our a value here, our b value here, that's our x value up there, and that's technically our y value there. So yes, this is in fact an exponential equation. Okay, so let's give this one a shot. $4,000 invested in a 3-year GIC, compounded yearly at a rate of 3.5% per annum. Identify the values for P, I, and N. So a GIC, that's something you can go to your bank and you can say, hey, I want to invest in a GIC. They'll take your money, invest it for you, and they'll give you the interest back at the end. So okay, so a p-value, that is our principal. That's what we're starting with. So for this one, it's going to be 4,000. That's what we're starting with. I is our interest rates. All right, so they're saying 3.5% every year. So that's 0.035. And 3 years, so of course our N value is going to be 3. So for this, we're going to need to use our compound interest formula. Which is this, right? So our p-value, 4,000, so we're starting with. Our I, interest rate, 0.035, and it's waiting 3 years, right? So I'm going to go in, 1 plus 0.035 is of course 1.035, and we're going to raise that to the power of 3. That gives us 1.108717, blah, blah, blah. And then once we have that, we multiply it by 4,000, and we get a value for our GIC of $4,434.87. Right? So essentially what we did, we went to the bank, we gave them $4,000, we came back after 3 years, they gave us back $4,400, or $4,434.87. Okay. And last one, whoops, what have I done? Last one we're going to do for today. Rena invested $8,000 in a 5-year bond, compounded annually at a rate of 3.2% per annum. Determine the interest earned at the end of the 5-year period. So that's going to be, again, it's compound interest, we know, because it's using words like compounded. P times 1 plus I, all to the power of n. So our principal value this time, 8,000. This one's going to be 0.032, and it's 5 years, so we raise that to the power of 5. All right. So for this one, we're just going to do 1.032. Raise that to the power of 5. You get an answer of 1.1705729, blah, blah, blah. And then, of course, we just multiply it by the 8,000. And what we get here for this one is $9,000, 364, $1.58. Just keep in mind, obviously, we're working with money here, so you should be rounding to 2 decimal places. Okay, so there's more. We're not quite done this section yet. We have quite a bit more to go through, but we're going to end it there for today with a nice little introduction to compound interest. So what I got you to do last time is I got you to just do question 1 because that was the only simple interest questions that we had. So what we're going to do now is, or what I'm going to ask you to do now, is to go to page 507. That's where the questions start for this assignment. And I'm going to have you do questions 2 all the way to question 7. So questions 2 to 7. Those deal with compound interest. After that, we have 2 more things that we want to cover here. I'll probably end up covering them both at the start of next week. But for now, just make sure you're working through the compound interest questions and try your best with those. Okay? So stay safe out there, everybody, and I'll see you next week. Bye.